Morning to you all. Yesterday we have seen how to obtain state space model of mechanical system and the electrical system. Today we are going to see. So how to get physical system? There are 4 methods available. One is called controllable canonical realization, observable canonical realization, cascade form realization, and parallel form realization. First, let us see controllable canonical realization. By directly by seeing one example, we can realize that. Here, one transfer function is given. We have to realize controllable canonical form. What is controllable form? We will see later. Controllable systems, observable systems are there. What is controllable? What is observable? That we will see later in this chapter. One simple sum will be there in controllable. Check whether the system is controllable. Check whether the system is observable. We can observe sun. We can observe moon. Can you control? So these are all example for observable system. We can observe, that's all. The displacement, how it displays. In a day, it rotates, the earth rotation. In a day, the earth rotates itself one time. 24 hours, it rotates itself one time. It is observable system, not controllable system. Similarly, all physical systems, maybe sometimes it is observable system, sometimes some variables are observable variables, some variables are controllable variables. We have to check whether the system is controllable or not. If it is controllable, then only we can design a controller. Suppose I am controlling to control the speed of earth, means will it work out? No, because it is observable system. Similarly, if we have any system, we have to check whether it is controllable, observable, or both controllable and observable. Suppose it is controllable, not observable, means it is also difficult. If you observe, then only you can control. If you measure any, observable means measurable. If you measure any variable, then only you can control it. So all observable variables need not be controllable variables. All controllable variables need not be observable variables. Both may be there, both may not be there. So here we are forming the transfer function can be converted into observable system as well as controllable system. How to convert them into controllable canonical realization? If you realize this way, it will be definitely controllable. Not sure that it is observable. Controllable observable means, suppose it is a second order system, means how many state variables there? X1, X2. If both variables are controllable, then the system is controllable. Suppose X1 is controllable, X2 is not controllable, it means the system is not controllable. It is not completely controllable. You can control X1, but you cannot control X2. If both are controllable, then only it is called controllable system. Similarly, X1 is observable, X2 is not observable, means it is not observable. But both X1 and X2 are observable, then the system is said to be observable system. Here, if you design this way, if you realize this way, realization means finding physical system for given transfer function. If you realize the given system like this, it will be controllable. For that, H of s equal to what? Y of s upon X of s. H of s is transfer function. That is output by input equal to x2, s plus 2 divided by s plus 5. This can also be written as y of s upon x1 of s multiplied by x1 of s by x of s. I am deliberately writing like that. That is equal to s plus 2 multiplied by 1 by s plus 5. This is equal to this. This is equal to this. This way I am separating. First, let us take x1 of s upon x of s equal to 1 by s plus 5. What you will get? S x1 of s plus 5 x1 of s equal to x of s. Or s x1 of s is x1 dot multiply by s means derivative x1 dot of t or simply x1 of t. Simply x1 of t. Hereafter we have put the t in bracket. x1 dot of t plus 5 x1 equal to x of t. x1 dot of t plus 5 x1 of t equal to x. Or it can be written as x1 dot equal to x minus 5 x1. This is one equation. Now take this. Take this. What is this? Y of s upon x1 of s equal to s plus 2. Or y of s equal to s x1 of s plus 2 x1 of s. Or y of t equal to, the output y of t equal to x1 dot plus 2 x1 of t. This is second equation. This is first equation. By using these two, we can simulate. We can find a physical system. First, we have to simulate the first equation. x1 dot equal to x minus 5 x1. Let us assume that x1 is available. x1 is available. As I said earlier, we are assuming that x1 is available. Take 5 times x1. Take 5 times. Amplifier gain is 5. You are getting 5 times x1. 5 x1 available here. It is subtracted. Here, x of s is given, or x is given here. X of t is given here. Or x of s is given here. Here, x1 of s. Both ways you can write. So put an integrator. Here, what you will get? X of t minus 5 x1 of t is x1 dot of t. x1 dot of t. Put an integrator. 1 by s. You will get x1. If you integrate x1 dot, you will get x1. That's all. The first equation is simulated. Physical system for first equation is made. What and all required? One integrator and one summer. If you have one integrator and one summer, you will get one summing junction. That is summer and integrator is there. We can realize the first equation. Second equation, only summer is required. What is that? Y of t. Let us assume that y of t is available. Y of t is available. Y of t equal to what? x1 dot plus, take x1 dot from here and add to get y of t, because y of t equal to x1 dot plus 2 times x1. x1 is available here. Multiply 2 times and give it here. So if you give x of t here, you will get y of t, the output. So this type of realization is called controllable canonical form.